Hello everyone, I hope you all are doing well. So today we will start with the chapter functions. Now this chapter is considered to be a very important chapter for JEE Mains because if you look at the previous year JEE Mains question papers, you are going to see that in almost each and every paper there has been one or more than one questions from this chapter. Also, this chapter builds up your base to learn more further chapters that we are going to study. So definitely an important chapter for you to study thoroughly and practice well. So let's look at what are the topics that we are going to cover in this chapter. First, we'll look at a brief introduction as to what functions are, how do they work, and we are going to connect functions with relations that we studied in our previous lecture series, which was on sets and relations. Then we'll look at a few more things: domain, range. Then we'll look at types of functions, how can they be classified into different formats, inverse, and then a few standard equations that you would be needed to remember so that it becomes easier for you to solve questions during your examination. So let's start. What is a function? A function is basically a special type of relation. Again, a function is a relation that associates each element of a set with exactly one element of another set. That means each element of my set A should be mapped with one element of another set. Now, there are a few things that you need to remember, that whenever I'm mapping this, so this mapping, or we can also call it as association, this is always unique for functions. This is always unique for functions. So mathematically, a function from set A to set B is written as f a extended to b. This means that each element of A, there is exactly one element in set B. Now, if I was to explain this entire term of function to you in the terms of relations that we studied. So what I'll do is, first, let me consider a set A which has elements, let's say A, B and C. I'll take another set B which has elements, let's say 1, 2 and 3. So for a function, what are the different subsets or what are the different relations which I can call as a function? So I'll show you different relations, different types of mappings of elements, and then from there we'll find out which one are functions. So before I do that, let me give you a few points. One thing that you need to remember: for every input, there is going to be just one output. There can be multiple inputs giving the same output. So for example, let's say if I have input as A and B, I am getting the output 1 for both of them. That is possible. However, for A input, I cannot have multiple outputs. Let's say if I'm mapping A to 1 and 2 simultaneously, that is not a case. That cannot be occurring for a function. And for a function, each and every value in the input or the domain portion should be mapped to one or more than one values in the output. That means none of the values in my first set should be remained empty. So now let me show you examples by doing the representation of relations. Let's say we have this set A, B, C, and this is my set 1, 2, 3. Let's say if I map A to 1, B to 2, C to 3. Would I call this a function? Yes, this is a function. This is a function. So this relation is basically a function. Let's say if I have A, B, C. Let's say my values are mapped in this order. A gives 1, B gives 1, and C also gives me 1. Would I call this a function? Yes. Every element of A has been mapped. Now it is not necessary that every element of B needs to be mapped. For my domain, codomain, if there are a few values which are left out, it is fine. It can still be considered as a function. However, for domain, each and every value should be mapped. Now let's say if I have A, B, C. Let's say A goes to 1, B goes to 2. That's all. C is not mapped at all. then this cannot be considered a function. Not a function. Each and every element should be mapped to elements of B. Now let's say if I have A, B and C, if I have 1, 2, 3, let's say from A I'm getting 1 and from A only I'm mapping 2. Would this be called a function? No. This is also not a function. Because from one input I cannot get two outputs. Always, even in any function, if I have one output, I'm going to get just one output only. Now let's say if I have a function A, B, C, sorry, I have a relation 1, 2, 3. A is going to B, B is mapped to 1 and C is mapped to 3. Would I call this a function? Yes, this can be called a function. You can see that each and every element of A has been mapped and there are multiple inputs for one single output. That means there are no multiple inputs for one single output. You must understand the difference here. I can have multiple inputs and one output, but I cannot have multiple outputs for one input. So let me write it down for you. We can have multiple inputs for same output, but not multiple outputs for same input. For it to be a function. Be a function. And you must also remember that each and every element in A should be mapped to any of the elements in my codomain, which is my B. Now, if I was to tell you what would be the number of functions that can be found out from my set A and set B. So let's say if my set A has m number of elements, my set B has n number of elements. So my total number of functions possible from A to B would be n to the power m. Now I hope you all remember when we had studied the total number of relations that could have been possible when we are mapping set A and set B. It used to be 2 to the power P into Q, where P used to be the elements of set A and Q used to be the elements of set B. So now here what we are doing is, since we have to map each and every element and we cannot map one element to two outputs, so that is why our value becomes a little less. It becomes n to the power m, or we can say p to the power q as well. Now whether or not to check if the equations or the things that have been provided to you are a function or not. So there is a graphical method which is the most easiest way to check it out, is the vertical line test. What happens is, let's say this is my coordinate axis and I have a graph in this way. This is my graphical function. What I do is I take any element of x and I draw a vertical straight line. For this value of x, how many values of y am I getting? So here we can see that I am getting two values of y. This is my y2, this is my y1. Here what I consider is x is my input and y is my output. So as we had studied here, as per relation theorem, what we can say is that for one input I need to have one output only. That means I cannot have multiple outputs. So this is not a function. Not a function. So now let me take a few more examples. Let's say if I have a function in this format, again I'll do a vertical line test. I'll take one of the x. At this point I'll draw a vertical line. Now at this x, it is intersecting the curve at more than 1 point, so it is also not a function. Let's say if I have a function in this format, one portion above the x-axis and one portion below the x-axis. Again the same thing. I'll take one x, I'll draw a straight line. Again, I can see that it is intersecting the curve at 2 points. That means I can have two values of y possible, right? So this is also not a function. A function would only be possible if for each value of x I have just one output. For each value of x I have just one output. So this is my function. So remember these few small things about functions. It can come handy while solving questions as well. So now we'll begin with what domain, codomain and range are and how can they be calculated for any type of functions.